All right, in previous videos, you've seen me use the Turbo Pascal bin to obj utility, and I've used the Turbo C version as well, which is named BGI OBJ. They basically do the same thing. Anyway, I decided I should write my own version of this utility and do a Windows GUI version, and this is the result right here. It's open source. There should be a link in the description to GitHub. I've also included the all the sources I've used to find out all the information about the OBJ format or OMF format and their sample C source code and Pascal source code. I took the best things out of all the source I found and basically I've created my own version in Lazarus. So this is the Pascal code here. I just whip right through it. So I've built a little library out of it. You're free to use this if you want to create an enhanced version, but as of right now, it looks like this works pretty well. And I'm just going to demonstrate its use. So you see me in previous videos take an image and convert it into an array and basically display that image with the put command or put image command. And let me just show you how that code looks. So in this example here, if we convert this to an array, go through the export, select Open Watcom, and choose to create put image array. If we jump here, this is what you'll see. This is a big array of the image, and we basically use the put image command to display it. So I could take this chunk right here. Let's just do this quickly. And let's jump to our demo here. So I'm going to comment this part out and just paste this in. And let's also comment this part out, save it. And I'm going to jump to my DOSBox command line and let's compile it. So this will compile using the 16-bit version of the compiler, and we will not link any object files. And so it created an executable. Let's take a look. So it's this one right here, OW demo. And let's run this. So we can see it displayed the image. Now let's say you don't want to do this. You don't want to copy a whole array or keep track of big array statements like this. Well, this is where the new utility comes in. Now you could have done this before using the Borland version of of their tool. It also works with Watcom, so you're free to use that if you're used to using things in DOS. But this works in Windows, so it makes things a little easier. So I'm going to go and do the same thing, but this time instead of exporting to an array, I'm going to export to a file. So we're going to go through the same step, and we're going to choose put image file. Now I already saved this before, so we see it right here. I'm going to overwrite this just to show you that it's before I overwrite it, let me just color one of the letters a different color so we can actually see that it's working. Let's do two colors. So let's export this, put image file, and overwrite this. So notice the extension XGF, and we're going to jump to my binary to object converter. So we're going to go in file, and we're in the same directory but from Windows, so it's under DOSBox temp OW. And I'm going to choose that file that I just saved or exported, this one, ow.xgf. Open it. Now I didn't choose Open Watcom, so I'm going to switch this again and re-import. You'll see that if we do it now, that everything is lowercase and there's an underscore in front. So this is the preferred format for linking any C externals. You have to put the underscore in front, and usually everything is lowercase. You could change the case, but that has to match up with your source code. And so first I'm going to do the 16-bit version. So let's save it as an object file, and I'm going to overwrite this object file right here, ow.obj. Yes, overwrite. And we get a message here that it created and saved successfully. And let's jump to the DOS command line. Here we go. Before we do that, we need to uncomment this out. So we're going to be referencing the object file, and OW is the name. This is the same as the array name before, but you'll notice the array is gone. And we also have an OW size. This tells us the size of the file. And when we're using 16-bit, I'm going to print out the size at the end. So we should be using this statement right here. So let's just save it. So everything's up to date now. And so this command should launch the 16-bit version of the compiler for DOS, compile the C source, and also link the ow.obj. So if we run this, we should get a new exe. And if we run the exe, we should get the colored version of the 2 letters now. And there it is. It works as expected. See, is the size right? Yep. So the size also displays properly. It's 8198. And if we look here, the original XGF file is 8198. So it gives us the correct size. Now, just to test this, the different object formats, let's go back into the utility and now select the 32-bit version. And let's overwrite this object file just to see if the compiler and linker notice any difference. So now it should be creating an object file that's 32-bit compatible. So let's perform the same step. So this ow.obj has been overwritten, and let's try compiling with the 16-bit compiler, trying to link the 32-bit obj. Okay, so it gave us a warning, but it did it anyway. So it says, warning, W1080 file is a 32-bit object file. So it recognized that it's a 32-bit object file, but it still created our 16-bit executable. So let's see if it actually runs still. All right. Yeah. And everything still works successfully. So even though it worked, I wouldn't recommend doing this because once you get into files that are larger than 64K, which the 32-bit version works with, the 16-bit version will not. So that's the only thing you have to be aware of, that when you're using the larger files. So I would always just match up. If you're creating 32-bit programs, use the 32-bit option. 16-bit, use the 16-bit option. You can't add larger files to the 16-bit version. It just won't do. Once you pass 64K, it will only load the first 64K. So that the program cannot pass that limit. It's basically a DOS limit, and there's no way around that. Not that I'm aware of. So let's switch to the source to the 32-bit version now. So let's switch this to long here, and resave it. And now let's use So this is the command line to execute the 32-bit version and create a 32-bit executable. So our source and our object file, and see if we get any kinds of warnings this time. So no warnings this time. It was happy with the object file, and let's just run it to see that it actually works. And it works, and proper file size. So that's the steps to use to create your own programs with images from my program, but you could also use this tool to attach anything to your exe. So if you have an audio file or any other kind of binary data, you can include it, and this is how you access it. You have to put the match up the variable name. So OW here, OW size matches up exactly with these variables right here, the public name and public size name. So as long as you match these up, you should be able to access your data. So this is the easiest way to, show the use, but like I say, you could use it for any other types of files. So you could add text files if you like. You can convert them to object files and link them. Any file basically. So I think that's as much as I can show for now. In future videos, I'll demonstrate this with other compilers like Turbo Pascal or Turbo C. But this utility should work with most compilers that support the DOS object format or OMF format, as it's technically known. So if you have any questions, leave in the comments or reach me by email. Everything is on GitHub again. There's a link. All right, that's it for now. Thanks for watching.